Good morning, everyone. Today, inshallah, we will continue on what we have started in the previous lecture. So today, we are going to continue with the operation on matrices. Already we identified matrices in the previous lecture. Today, I will continue this. Of course, all the course records, stuff, materials, whatever, you will find it on Model. So there will be no problem about this. Also for the recorded lectures, you can find them easily on YouTube, okay? So it's not gonna be a problem, inshallah. I want you to remember the following. They sent me that on a previous email, and I want you to know it.
This is the enrollment.
First student should enroll on our model. This is the bus for linear algebra with programming, section entered. Okay, students should download Anaconda and execute the files. I've spoken with Dr. Imam and Dr. Muhammad, and there will be a support by the end of next week. Tomorrow, today, inshallah, if I get the chance to meet with Dr. Muhammad, I will go through it with him. And I've downloaded Anaconda for myself. As I told you in the previous lecture, I didn't work with Python before, but I will try to do so soon, as fast as possible. And I've told also Dr. Muhammad to start up with you as quick as possible to go through the Python programming. The programs which are supported here or exist here as a training for you, it's a straightforward program. So all you have to do is to enter the couple of lines and to see how the array is going to appear to you, okay? And we will go through it together. They should start studying the slides, maybe slide 10 or 8. We will go through all of this and we will proceed also. Ask them to see the rest of the slides from section 1 to 1. This is what I told you about in the previous lecture. You will have to study not just only for this week, but apart from the next lectures. They want to develop your senses about studying something you didn't hear about from the lectures. So step by step, you will increase your abilities to enter something or not to be afraid to go through something you didn't hear about, okay? And it's really a little bit benefitable. If you tried it, it's gonna be very good. Okay, do some exercises. We will have some today, and the rest I want you to try it by your own, okay? This is supposed to be the landscape for September. If you like to take a photo for this, it's nice. As you can see, we have here on Wednesday, this is quiz 1. As I told you, through our course we will have 8 quizzes. The highest 6 of them, you will be granted for them, okay? So he will seek the best 6 quizzes for you, I will consider, and it will be considered, and it has 5% on these quizzes. Another thing, this quiz is really very important, especially the group of quizzes which starts within the first chapter or through September. Those are really very easy ones, so you should be keen to have them with you and to get the highest marks possible, okay? Very good. Okay, remember with me, in the previous session, we spoke about matrices. We know that a matrices is an array of numbers that are arranged in rows and columns. Each one of these entries, it already contains 2 numbers in your mind. The first of them stands for the row, the second stands for the column. So each one of them is fixed in its place and by its row and the column number. This was covered in the previous lecture. What's really important, it should be in your mind, something very easy. This is what's called the principal diagonal, or the main diagonal, or the first diagonal. The other diagonal, it's called the secondary, or the second diagonal. You will need that down the road if you are trying to expand the determinants, which is relative to matrices, as we will go through shortly, inshallah. Remember, the column matrix are all the matrices. That's the number of columns is equal to 1, which means you will have a lot of rows, but just only with 1 column. This one is gonna be like, if we say 3, 4, 2, anyone can give me the dimension of this matrix? Huh? Any suggestions? 3 times 1. So it's a 3 rows, 1 column. Of course, for the row matrix, it will be the vice versa. You will have 1 row and a multiple of columns. So for this one, it's gonna be like this. Let's say 3, 2, 1, 0. Anyone to give me the dimension? This is 1 row times 4 columns. Here's the what's called an upper triangular matrix. I think we did go through it previously. The upper triangular matrix is simply a square matrix. Let's say 3, 2, 1, 2, whatever, 5, 6. The remaining elements are zeros. So as you can see above the principal diagonals, you have numbers. Below it, it's all zeros. See how it is written. It's really very important to get too familiar with how it's gonna write this. See, Tala, you see? For the upper triangular matrices, if A is a square matrix and Aij stands for all the elements, but with a specific property, that's I is greater than J. If you remark, you will find this value, the number of A is greater than J, and also for the rest of these values. I'm sorry, for this one. Here I is 2 and J is 1, so it's 0. Here's R is 3 and J is 1, so still I is greater than J, so it's going to be 0, and so on. So see how we succeeded in writing this like that in order to outline that these are the entries which are zeros. في الآخر our triangular matrix هتلاقي numbers, it's like a triangle above there. طب لو lower triangular, just that one second. لو lower triangular matrix, it's going to be exactly the same. It's like this. So you will find the triangle of numbers below the diagonal line. Okay, I'm with you.
The expression Aij equals 0, it's all elements I less than J and no.
This one?
This one, yes.
Yes.
All elements of I are less than J and the other and
no, all elements of I is greater than J.
Greater than, yes.
Yes. And the vice versa
is
for the lower triangle.
Yes. Okay.
Exactly. Okay, for the zero matrix, or sometimes we call it the null matrix. The zero matrix is the addition and subtraction identity. وده برضه احنا قلنا المره اللي فاتت. طبعا عندك diagonal matrix of A, it's a square matrix. A of ij equals 0 for every I doesn't equal to J. طلع, can you imagine how this matrix, the diagonal matrix, looks like? Can you imagine it? Huh? So it's gonna be 3, 4, 6, 0, 0, 0, 0, 0, 0. That's a diagonal matrix. A special case from a diagonal matrix in the unit matrix. Do you remember it? We spoke about it in the previous lecture. This is what's called a unit matrix. Okay? The unit matrix, it's important because it's bringing the identity of multiplication.
So that you reduce echelon form?
No, this is gonna be the reduced echelon form down the road after we take the operations. Okay, we will be seeking to reach this form, but this is what's called I matrix of 3 by 3. If we are talking about a 2 by 2 matrix, if you remember, this is the last thing that we spoke about in the previous lecture. This is a 2 by 2. If it was 1 to 1, can you imagine for us? How is it 1 to 1? Just. Very good. ده كده السلايد ده زي ما انت شايف الديفينيشنز دي كلها احنا اتكلمنا عنها. تمام حلو قوي. خلي بالك these definitions are important because down the road he will just mention them. We will mention them and you can imagine the size of the matrix or its properties. Okay. Once more, he's talking about the row matrix and the column matrix. Vectors mainly, it's like row matrices, okay? So we can deal with them like this. either in the form of a row or a column matrix. This is the identity matrix that I told you about. For I equal to j, it's equal to 1. For I not equal to j, they will be zeros. Before we leave this, there is what's called a scalar matrix. The scalar matrix is exactly a unit matrix, but the diagonal are multiplied in one number, like C.
So it's the identical unit
This
matrix.
is called a scalar matrix. So it equal to 3 times
the unit matrix.
the unit matrix. So it's called a scalar matrix. Also, I want you to know it in the back of your mind. Okay, more than perfect. Okay. Here he's talking to you two matrices A, B, or C to be okay. We already spoke also about this. For two matrices to be equal, they will have to have same dimensions. So if I have a matrix 2 by 2, it's going to equal to another matrix which is 2 by 2, 3 by 3, same dimension. And the elements will be equal to each other correspondingly. So the element 1, 1 in A will equal to the element 1 and 1 in B, and so on. So it's really very simple for the equality in matrices, but they have to be copies from each other. To say that matrix A equal to matrix B, it means they have the same dimension, same numbers, same positions, same everything. Okay? If you have addition or subtraction between matrices, it's really very simple. They have to be from the same dimension. So same number of rows, same number of columns, and simply you will start adding the corresponding elements to each other. And شوف examples, we'll see examples down the road. These propositions are really very important. It's committed B plus A equal to A plus B. If I have three matrices, I can get the sum of two of them, then on the third one. It's exactly the same. If we get B plus C, then we add to A. Remark, 0 is the identity or the null matrix, which is a matrix with any dimension. All the elements are zeros. It's playing the identity of addition or subtraction. If you multiply a scalar times a sum of two matrices, it can be distributed on both of them. معايا شباب؟ في أي مشاكل? Any problems? Any questions? If I have k plus s times a, it means we can distribute these values on a. Similarly, like if you have two scalars multiplied in a, you can multiply them together first, then it will be multiplied in your matrix down the road. So it's really very simple. What I really need you to understand, everything, the minor things that makes the huge differences. معايا يا رامي؟ Okay. طيب, I want to get A plus B. Anyone? How to get A plus B? And then I will get 3A. قول رامي.
Okay, so first of all, I write both.
So it's gonna be 0 plus negative 2, it's negative 2, 5 plus 0. 5 negative 2 plus negative 2 is going to come up to negative 4.
0.
So it's going to be 0.
Okay.
Then 4.
So 4
finally,
and
7. Yes? Did I make any mistakes?
No.
Okay. Okay. Let's see if we got 3 times 8. 3A. Tala? How to do 3A? Multiply 3 in all the elements. Yep. Okay. 15 minus 6. Yes. 3. Then 9. Then 3. So I think it's really very easy to get like 2A minus 3B. Is it easy? How are we going to do it first? How to get 2A minus 3B? Can you write, can you choose in a multiple choice the element 1, 1? If I make you a quiz on this, you have two matrices, and then just asking you about the value of A, 1, 2. Can you do it? I need the entry A, 1, 2 in the new matrix. Anyone?
We just multiply 2 by the first.
Get that number. So I'll start with
It's going to be
1, 2.
0 and negative 4.
Where is 1, 2?
5.
Where is 1, 2? This is 5. Where is 1, 2?
0.
0. Then I will do what you said. 2 times 5, it's gonna be 10 minus 3 times
0.
0. So this is actually the value of A12 in specific. طبعا انت فاهماني؟ فاهم انا عملت ايه؟ انا عايزك تجيبي. اوكي انا عايز انت فاهم انا عايز اجيب ايه؟ انا عايز اعرف in the result I needed in specific the value of A12.
دي 1 2 12 صح؟
ايه؟
لا
1 2.
طب وال 3 A minus
First row, second column.
طب ال 2 A minus 3 can I get this one?
These are the two matrices. Those matrices. Multiply the first by 2, then multiply the second by negative 3. Yes, yes. It's like numbers exactly. It's like numbers
Instead of
exactly.
doing both matrices in full, just do the corresponding unit that he's asking for.
What?
Instead of doing both matrices in full, just do the corresponding
Yes.
entry that he wants.
Yes. You can do them all and choose the value, but it's smarter just to do it that way. Okay. Omar, صح? Can you get me the value of A23? A23. ها؟ طيب يعني إذا we can't get this. طب can you get the value of A32?
1.
Huh? So this is 1. That's
6.
I want to map this 2 times 1. Then negative 3 times 6, which is gonna come up to 2 minus 18, which is gonna be negative 16. So if it was a multiple choice problem, you will choose simply the value of negative 16. I want you to expect that maybe you may be asked about something like this. It's really very simple, very tiny, but look from my point of view. If I asked you about something like this, I've gained. Now I know that you know exactly the dimension, the entries, how to get the specific value exactly. Okay, so I have already did go through the understanding of all the properties relative to matrices from addition, subtraction, multiplication, blah blah blah. Okay, very good. Is it? Division is a little bit tricky. We will go through it, but not today.
Is division like multiplication but divided?
No, it's a little bit complicated in matrices. We will go through it. It contains some steps, but we will do it. Okay. He's spoken about multiplication of matrices, and we spoke about this in the previous session. I've also given you how to multiply two matrices in each other. This is a place where you will face a lot of questions because it's different than the normal multiplication. And also, one of the really very important properties of multiplication in matrices, it's not commutative. That's A times B, it's not going to equal to B times A. This is for the majority of problems. Here he's saying to you, here what we say, A times B doesn't equal to B, we can't generalize it, okay? This problem, it's not bad, it's nice. I want to get A times B. Anyone? A times B. Any suggestions?
As 1 times
So 1,
times 3.
0, negative 1, then negative 3, 2, 2,
4,
4, 1, and 5. And this is times B, which is
B1.
3, 1, negative 2. Is it, first of all, is it possible
Yes.
to multiply these two matrices?
Yes, is equal to the number.
Yes. The condition states that A is a 3 by 3 matrix, B is a 3 rows times 1 column. In order to do multiplication, the columns, because you didn't attend in the previous lecture, the columns of the first matrix must equal to the rows of the second matrix. So here it is possible to make this multiplication. Is it possible to get B times A?
No.
No,
No, it's not gonna be possible. Because B is 3 times 1 and A is 3 times 3, so it's not even possible to go through multiplication. How to do multiplication? Go.
الرو ده هيتقال مع كل واحد فيهم.
First row times first column. That means the element A1 1. First row معلش ركز قوي في الحته دي. First row first column 1 1 يبقى انت بتتكلم على الاليمنت A1 1. Start the multiplication. Start 1 times 3. I do it with my both hands. 1 times 3, which is going to be 3, plus 0 times 1, which is 0. The sum is 3. Then negative 1 times negative 2, which is going to be positive 2. 3 plus positive 2 is going to come up to 5. I will write it for you. It's going to be 1 times 3, then plus 0 times 1, then negative 1 times negative 2. You will end up having just only 5. Can you do it once more, Galal? Second row, first column. Huh? Negative 9 plus 2, so it's going to be negative 7. Then minus 4. Negative 7 minus 4 is going to be negative 11. So it's going to be negative 11. And this is A1 2. For A1 3, same way like 4 times 3 is going to be 12. Then 1, so it's going to come up to 13. Then minus 10, so it's going to come up to just only 3. Okay? شباب مهم قوي انك انت تحاول ستيب باي ستيب انك تجمع الايه؟ الحركه دي ستيب باي ستيب.
أنا عندي observation. هو
Okay.
أنا لو I have a question similar to this. بس I cannot, for example, let's say the number of rows and columns are equal. Couldn't I necessarily multiply matrix A by the transpose of matrix B in order to have the matrix, in order to have it be able to multiply?
No.
But that doesn't make sense because in the for example,
I want you to train yourself on the steps that we are doing once, twice, 3 times, and then it will be easy for you.
no, I understand this.
I know you understand, but for the time being, just keep it this way. After we finish, we will talk together. Okay? ها شباب واضح؟ في مشاكل؟ Okay, perfect. على بقى انا كل ده مش ده اللي انا عايز اكلمك فيه. كل ده كان بسيط. طبعا ده A times B. هنا he multiplied the first row by the column. He wrote them together and then multiplied.
بيطلع اول كولوم بس في الاخر.
ليه؟
عشان هي مش ايكوال.
عشان ايه؟ why؟ لأن ده 3 by 3 ده 3 times 1. So the result will be 3 times 1. But if B is 3 times 2, so the result will be
3 by 2.
3 by 2. So if B is 3 by 3, the result will be 3 by 3 matrix. فاهمني؟
So it all depends on the
Are you sure?
dimension.
شو بس هو الكلام بس لو
فاهم مثال يعني؟
ممكن.
طب استنى. بس في امثله كتير دلوقتي. بس هيجي هنا ونتكلم عليه، ماشي؟ ارجع بقى معايا كده تاني. احنا اتكلمنا على ايه؟ اتكلمنا على ده. طيب دلوقتي عايز اكلمك على particular cases. A square matrix is said to be اي خلاص upper triangular lower triangular diagonal. This is very important. في حاجه اسمها transpose of a matrix. Transpose of a matrix. These two properties are important. This one and that one. If I have a matrix like this, see A is defined by 2, 0, negative 1, 3. I want you to get A transpose. The transpose of a matrix, it means that you will change the column to be rows and the rows to be columns around the principal diagonal. How to do it? First of all, consider the 2 as a pivot. So it's 2 and 0. Just move it to be the first column, and the numbers that exist in these columns, it will go in the side of a row. So simply, it's going to be 2, 0. Instead, the 0 that came into a column, you will have instead negative 1. So this is be the transpose of this one. Right, let's try if I have 3, 2, 1, 0, 0, 2, negative 1, 6, and 3. Something like this. This is the A matrix. I want to get A transpose. Any suggestions?
0, 0, 3.
So the first row will be
0, 0.
the column will be a row. So it's gonna be 3, 0, 0. Instead of the values which are there on the previous one, it's gonna be the column. So it's gonna be 2 and 1. The number on the principal diagonal, it will remain the same. So it is 2. Instead of the row 0, 2, 6, it's gonna be the column 0, 2, and 6. For the last row, instead of having 0, minus 1, and 3, it's gonna be 0, minus 1, and 3. This is how we get the transpose of a matrix. Just changing the rows instead of into columns and vice versa.
Don't do the transpose by just rotating the entire matrix like clockwise.
Yes, but around the principal diagonal. The simplest way to do this is to take the first column, okay, and you rotate it to be the first one. And the result and the numbers will go.
Clockwise, because clockwise
yes.
it would be 0, 0, 3.
Yeah.
So it's anti-clockwise.
Yes.
Okay.
But you will have to check that. Okay, Tala? You will have to check. This is the first row, it is the first column. This is the second row, second column. It's written right. And the diagonals are in its place. There is what's called a symmetric matrix. The symmetric matrix is one of the very unique matrices. And the anti-symmetric matrices or matrices also is very unique. I want to show you an example of a symmetric matrix. The symmetric matrices, they have identical values around the principal diagonal. So if I say was 3, 1, 1, 2, 6, 5, say 1, 1, and 6. Look at this matrix. If you remark, the upper triangular values is exactly the same like the lower triangular values. So look at this triangle. Look at that triangle. They are exactly the same. The value 1, 2 equal to the value 2, 1. The value 1, 3 equal to the value 3, 1. The value of 3 and 2 equal to the value of 2 and 3. See, the corresponding values around the principal diagonal are the same. This is called a symmetric matrix. One of the properties of the symmetric matrix is that its transpose equal to the main matrix. A equal A transpose. So if I gave you in an MCQ exam or something a bunch of matrices and I've said to you which one of them is a symmetric matrix, all you have to do is to try to get by your eyes the transpose. If it is the same, exactly the same, so it is a symmetric matrix. Another way to know about the symmetric matrices is that the elements are the same around the principal diagonal. Okay, for the skew symmetric matrices, the skew symmetric matrices will have this form. Was first of all, the principal diagonal, it's gonna be zeros. Must be zeros. For the symmetric, I don't care if they are zeros or not, as long as the upper triangle equal to the lower triangle. But for the anti-symmetric matrices, you will find the following. This is going to be 2, let's say, 3, and 4. You will find the exact values, but with negative signs. -2, -3, and -4. So the upper triangle is exactly the same like the lower triangle, but they have opposite signs. Of course, if this one is negative, you will find this one is positive. They are having the opposite signs, okay? This is why if you make a transpose of an A, then multiply by negative, it will regain to its shape. See this one. Anyone to bring the transpose of this matrix? Get the transpose of that matrix. So it's gonna be
0, 2, 3.
0, negative 2, and 3. Then you will have 2, 0, and 4. Okay? Then you will have negative 3, then 4, then 0. Look at this one, look at that one.
But isn't the 4 supposed to be negative?
Okay. 0, negative 2, 3. This is 2, 0, and 4. This is, yes. This is positive, 3, negative 4, and 0. No, that's not.
No.
Negative 3, 4, and 0. Yes, this is right.
2 لا في نيجاتيف 4 ناقص 2 3 اللي عايزين خالص ال 4
0,
نيجاتيف
negative 2, and 3. The second is going to be negative 0 and 4. The third one is going to be 3, negative 4. Yes. You're right. 3, negative 4, and 0. Remark, if I multiply the transpose in a negative sign, it will be the same. Let's multiply it in a negative sign. Multiply. 0 times negative, it will remain 0. So this one is going to be positive,
Negative.
negative, negative, positive, positive, negative. So it's exactly the same.
So multiplying an antisymmetric.
This is the antisymmetric matrix.
Multiplying an antisymmetric matrix by -1 just results in the original matrix.
Yes, exactly right. How to know it? You will find the upper triangular numbers exactly the same like the down, but with opposite signs. And the principal diagonal must equal to 0. Okay? Don't forget.
Always
Equal to 0. Or how are you going to multiply negative and it's not going to change? Okay, perfect. So these two properties now clear. Any questions on that? Any questions? Okay. Here's some properties about multiplication. If you have AB times C, mark, I can get the value of A times B, then the result will be multiplied in C, or getting BC then times A. You can distribute, but from the left or the right. If I have A times B plus D, so you are multiplying from the left. So it should be done from the left. So it's going to equal to A times B plus A times D. You can't do A times D, so I'm going to equal to it. Remember, in all times, that's multiplication is not commutative in matrices. Same way like here for the right multiplication. So here's left multiplication, here the right multiplication. If you have two matrices and their multiplication equal to the null matrix, this implies that one of them is the null matrix. It's not for sure to be like this. What I want to stress on, if I have A times B equal null matrix, this is not a necessary condition that A is a null matrix or B is a null matrix. It may happen. A and B, none of them is null matrices, but the result is gonna be 0, okay? I times A, okay. The only commutative matrices is once you multiply in the multiplication identity in the unit matrix. So you can multiply I times A or A times I, both of them will be the same, you will have the same matrix. Also, if you have scalars, K times AB, you can multiply K times A then B, or multiply K times B then times A. This is for a scalar thing. And it will make no difference since the value of K will be multiplied in all the elements in the matrix, okay? This is if you have A to the power of 2, so it means you will multiply A in itself 2 times. If 3 times, you will multiply 3 times, and so on. Okay. Here's if you have A to the power of R times A to the power of S, so it's going to be A to the power of R plus S. Do you understand me? Do you read me? Do you read me? So if I have matrix A 3 by 3 to the power of 2 times A matrix 3 by 3 to the power of 4, then you will add the power exactly like numbers. Okay, you read me? Perfect. Yes?
A and A, yes,
ايه
ده عشان دي ايه تبقى سكوير، يعني ده عشان حاجه تبقى سكوير ماتريكس.
لا، انت لما تضرب a to the power of r times a to the power of s
قصدي
على انهي واحد؟
لات ايه
هنا؟
فيها بالظبط لات ايه هي سكوير ماتريكس.
Okay, and the ROS belongs to n, the set of natural numbers, which is 1, 2, 3, 4, 0, stuff like that. Okay? This is a power of a bar.
طب ازاي نخلي حاجة سكوير ماتريكس؟
نخلي حاجة ايه؟
سكوير ماتريكس.
لا انت مش بتخليها سكوير ماتريكس، سكوير ماتريكس انت قصدك سكوير ماتريكس a to the power of 2 ولا square matrix the number of rows equal to the number of columns. طلع A is a matrix. It can be 2 by 2 or A it can be 3 times 4 which is 3 rows 4 columns. If I say A and that's it, it means all types of matrices. Okay? If I put just let A be a square matrix, so I'm talking about all the types of matrices with the number of rows equal to the number of columns. Okay? ننزل خلي بالك A transpose over transpose it will equal to A. يعني انت لفيتها كام مرة يا رامي؟ مرتين فترجع للأصل.
ينزلوا بعض.
خلي بالك من البروبابيلتي دي. A plus C transpose it will equal to A transpose by itself plus C transpose. K A to the power of T. It's gonna equal to K, make the transpose, then time by scalar. K is always a symbol, not for a matrix, but for a number. So multiplying like 2A, like 3A, معايا first. Remember this one. This is a new one. It's really very tricky. See, if I have AB transpose, it's going to equal to the B transpose first times the A transpose. Okay? Is it clear? معايا تلا? This is really very important. It's not going to equal to A transpose times B transpose. No. You will have to change them. Instead of having the A times B, it's going to be B times A. But then distribute the transpose.